Hello everyone. In this video we are going to do Trigonometrical Identities chapter 21 of class 10th ICSE board. So an introductory video of trigonometry I have already made one, so I have shared that in description. You can go through that, and here I'll be directly starting with the exercise. So just few formulas which are required in this exercise we'll discuss, then we'll start. So first one is the reciprocal relations. Reciprocal relations of the 6 trigonometrical identities. As we all know, we have 6 trigonometrical ratios. Sine, cosine. So in short, like in their abbreviations, I'll be writing sine, cosine, tangent, cotangent, cosecant and secant. So these are 6 trigonometrical ratios. So because it's the reciprocal relation, so we will be learning about their reciprocal relations only. So sine's reciprocal is cosecant, this one. So reciprocal means, we know the meaning of reciprocal. Reciprocal means interchanging of numerator into denominator. So sine is a reciprocal of cosecant. That means cosecant we can write it as 1 by cosecant. So here some angle we can write theta, theta we can take. Because cosecant we can assume that it is cosecant by 1. Because if nothing is written, that means in denominator there is 1. So sine is 1 by cosecant. Same way cos theta, cos it's a reciprocal of secant. So we can also write it as 1 by secant. Tangent, it's a reciprocal of cotangent. So I can write it as 1 by cot. So there, like, its abbreviation is only tan. So tan we can write it as tan theta is equals to 1 by cot theta. Now these three only you have to learn, sine, cos and tan, because same, see, the reciprocals they work the other ways also. If I see cotangent, which is cot, so cotangent if I see, we have learned that this is a reciprocal of tan. So if tan I can write it as 1 by cot, same way cot I can write it as 1 by tan. Cosecant or cosec theta, so we can, because it's a reciprocal of sine. So if sine can be written as 1 by cosecant, then cosecant can be written as 1 by sine. Secant, so secant mostly you will be seeing in their abbreviated form. So secant, SEC, you will see sec. Cosecant you will be seeing it as cosec. So that's why I'm just writing their short form only. So secant theta we have learned it's a reciprocal of cos. Cos if we can write as 1 by secant, so secant we can write as 1 by cos. So these are the reciprocal. So like I told you, only 3. If you learn, remaining 3 automatically you can learn. And the way to learn is that, see, sine, its reciprocal starts from C, because just a way to remember its starting point. Sine S, its reciprocal starts from C. Cos, it is starting from C, its reciprocal starts from S. Like SC, CS relations you can remember. And then cot, cot means cotangent. So in cot itself, see, full tangent is coming. So that means it's a reciprocal of tan. So this is one way you can remember, and at starting point it will be helpful. So apart from these 6 relations, one more relation you have to learn, or we can say 2 more. See, tan. Tan you can also write as sine theta by cos theta. Tan is sine theta by cos theta, and this, why it is sine by cos, this I have already explained in my first video of trigonometry. You can check out. So if sine by cos is tan, so So we know tan's reciprocal is cot. So that means if tan is sine by cos, so cot can also be written as cos by sine. So like two additional things, or moreover like I can say one additional thing. If this you know this automatically you can, because we know tan's reciprocal is cot. If tan is sine by cos, then cot will be cos by sine. So this 6 relations you have to remember for this exercise. And now the next relation. See, these are the reciprocal relations we have learned. Now let's learn about the square relations. So in square relations, we only have to learn 3 relations. In square relations, we have first one, cos square theta plus sine square theta, it is equals to 1. Cos square theta plus sine square is equals to 1. That means in square relations, cos and sine, they are related with each other. Next one is 1 plus tan square theta, it is equals to secant theta, secant square theta. Tan and secant, they are related with each other. And then 1 plus cot theta or cot square, because square relations we are doing, 1 plus cot square theta, it is equals to cosecant square theta. So only these 3 relations are there in square one. But the thing is that you have to remember which one is associated or which one is related with which one. Sine and cos, and the way I have written, try to learn in this way only. Sine plus cos, and then 1 plus tan and 1 plus cot, like that you can remember. So sine and cos, they are related with each other. Secant and tan, and then cosecant and cot. CC, then sine and cos, like because I told you in the first one itself you only have to remember sine, cos and tan. So now this way you can just remember sine and cos, they are related, then tan, secant, cot and cosecant. But all these things will come into you as we do more and more questions. So no need to worry here. Now let's start with the exercise. So let's start with the first question of exercise. It says prove the following. So proof type of questions means we have to prove left hand side equals to right hand side. So any one side, sometimes we have to prove both the sides, but mostly in most of the questions you have to prove this side equals to this or this equals. So it's your wish which side you want to prove. So I'll start with left hand side. So in these questions, see, I will be telling you few things, and out of those few things only you have to use and try to solve it. So let's start first one. First says that left hand side is secant A minus 1 upon secant A plus 1. This thing you have to prove equal to this. First very important thing is that we have to see this with equal to which thing we have to prove. So this we have to prove it equal to cos. So something with cos is there. So that means I have to change it to cos. See, first idea we will get from our left hand side only. So in the reciprocal relations we have already learned that cos theta is equals to 1 by secant theta. Or I can also say secant theta is equals to 1 by cos theta. So their reciprocal relation we have learned that cos and secant, they are reciprocal of each other. So what we can do, we can change it because we need to prove it equals to cos. So let's change it to cos. Secant A. Secant A, this one, here theta means some angle, here A is some angle. So secant theta is equals to 1 by cos theta. So let's change it 1 by cos A, because same angle you have to write. Minus 1 as it is. Here with this also let's change it 1 upon cos A plus 1, because this is some fraction. So what we can do, let's write it also in the form of fraction. Now in numerator and denominator you can see that addition and subtraction of two fractions. So when there is addition and subtraction of two fractions, we solve it by taking the LCM because denominators are not same. So here this one, top one, the denominators, one of the denominators is cos A and the other one is 1. So in this type of expressions, their LCM will be their multiplication. When this type of trigonometrical expressions you are getting, so their multiplication you have to take as LCM. So cos A into 1. Cos A into 1 will be cos A, as if we multiply any number with 1, the same answer we will get. 1 into 1. And what to write on the numerators, that will, it's their cross multiplication. So 1 into 1, 1, minus sign as it is. Here don't change any sign, minus sign as it is. And this side also cross multiplication. So cos A into 1. Into 1 means any number, whenever we multiply with 1, we'll get same number or same expression as the answer. So LCM is cos A, 1 into 1, 1, minus sign as it is because minus sign was there, and 1 into cos, that is cos A. Now this is my numerator, so I have solved it. Now same way let's solve denominator. So denominator is, again expression is same, so their LCM will be their multiplication of the denominator. So cos A into 1 is cos A. 1 into 1, 1, plus sign as it is, cos A into 1, cos A. Now this is, see, this is a sign of division. This is one fraction, this is one fraction. So when two fractions are getting divided, you multiply inner ones and outer ones. So how we can write this one? We can write it as, first you write, in order to reduce any confusion, first write this thing as it is. 1 minus cos A by cos A. Now like I told you, put a sign of multiplication. So this thing is getting multiplied by this. Inner ones will get multiplied, so outer ones will get multiplied. So here we will write cos A by 1 plus cos A, because this has to be get multiplied with this one. So 1 plus cos A. Because multiplicative terms we can do cancellation, same terms will get cancelled. So cos A and cos A will get cancelled, and what I am left with, it is 1 minus cos A by 1 plus cos A. And if you see, this is the right hand side, so hence proved. And you can also try proving the right hand side equals to left hand side by using this one. Same thing you will get this thing equals to this, but both the things at a time not required. Any one you can use with which you feel comfortable. So first one is done. Second one is also, it's a similar expression, only sine and cosecant are there. Now let's change, and in the reciprocal relations also we have learned that these two, they are reciprocal of each other. That means sine theta, it is equals to 1 by cosecant theta, and cosecant theta I can write it is equals to 1 by sine theta. So this thing we have to use. So let's start from left hand side. Left hand side is this 1 plus sine A upon 1 minus sine A. So like I told you, first step is to look at the right hand side. We need what? We need cosecant. So that means directly now we have to change its sign into cosecant. Very like simple thing. So we can change it 1 plus sine. Sine we know it is cosecant theta, 1 by cosecant. So I can write it as sine A as 1 by cosecant A. Same expression 1 minus 1 upon cosecant A, because they are reciprocal. So sine I change to cosecant here because it's a fraction. So let's write 1 also in the form of a fraction. Now this is addition of two fractions, this is subtraction of two fractions where their denominators are not same. So like simple numbers we do, if I have to add 1 by 2 plus 1 by 3, addition of two fractions, so I have to take their LCM because denominators are not same. So same concept we have to apply here also. we have to take their LCM to make the denominators same. So LCM of such expressions I have told you 1 into cosecant A, like the multiplication of denominators with each other. So 1 into cosecant A is cosecant A, and then their cross multiplication. So whatever we have to write here and here, like in the numerators, that we have to do by doing cross multiplication. So cosecant A into 1, that is cosecant A, because with 1 if you multiply anything we'll get the same thing or same expression. Again plus sign as it is, 1 into 1, 1. This one same thing, same type of expression with a minus sign. So 1 into cosecant A cross multiplication, cosecant A into 1, that is cosecant A, minus sign as it is, 1 into 1, 1. So their cross multiplication we are doing, and for LCM their direct multiplication we are doing. Now two fractions getting divided, because this is the sign of division. So this division will change it to multiplication. In inner ones we will multiply and in outer ones we will multiply. So first thing is you write this thing as it is. So cosecant A plus 1 by cosecant A. Put a sign of multiplication. Then outer ones will get multiplied. So outer one I have written, the other one is this. So I will write here cosecant A. Inner ones, first inner one I have written, second one is this, cosecant A minus 1. This and this will get cancelled, because see, 2 by 4 into 8 by 3. So we can do their cancellation. Same way, two fractions, when there is a multiplication sign in between, we can do cancellation this way. So that is why this and this will get cancelled. Up, down and sideways, up and down cancellation we can do. So cosecant A plus 1 into, because here like 2 by 2 if we do cancellation, what we will get? 1. Same numbers, so same thing. If this I am cancelling it with this one, same expression, so that means 1 I will get. So this into 1, 1, and this into 1 again. This into 1 means same expression, and again here 1. So with 1 if you multiply, same expression. So this we can see it is equals to right hand side also.